Yeah, we left out a couple things didn't finish from the previous video. So after we finish the pop, you can see if you have first node, so then we need to have the temp refer to the first node, then first node assigned to the next one. So we can delete the temp. So then we decrement size. So what we left out here is we didn't have the copy constructor, assignment operator, and the destructor finish. So the destructor actually is the clear function. So we just write the clear. Okay, so your clear actually is still the same as before because they will pop from the first node. So actually what we change is only instead of you use the while or use the if, we do the while loop. So that's your clear. So the same thing, this one is also your destructor function. But this one we need to be careful because before we only check the last node and decrement the size. But here, since after we do the clear, right, we also have the last node. So that's here. Only when you do the clear, so then you need to see the last node equal to 0. For your clear, you need to be careful to change that. So the same thing for the destructor function. Okay. So actually so here we only have copy constructor and the assignment operator we didn't finish. But actually the copy constructor and the assignment operator, these two will be exactly the same as the stack implementation. So the only thing is before the stack using the last node is the temporary local variable. But now we do have the last node. So that's why here I won't repeat about the assignment operator and the copy constructor. They will be exactly the same as your implementation in the queue linked list. Actually here we have one correction about the pop. Okay, because earlier remember when we do the clear, so that's the while loop. So if we do the pop, for the clear, we need to change at the end the last node equal to 0. So when we do the pop, we also need to be careful because pop is we do the if statement, right? So now if first node equal to 0, we have not equal to 0, we can delete node. But one thing is be careful if after your size decrement, right? So then here, if that's the last node, we delete. So that's why here you can do is, if now after you delete that node, if size equal to 0, at that time actually we need to make our last node equal to 0. If that's the last object available in the stack. So you can refer to here if you forgot about the copy constructor or assignment operator we have from last week for the stack linked list. So here is the example. You can refresh your memory. So that's the for loop we can copy over one by one. So this week it will be exactly the same we can apply for the queue linked list. Just one thing is from last week, the last node is the local variable. But this week, when we copy over from the assignment operator, they're still doing the same for loop. But this time, the last node actually is the data member from the host object. So now you actually can working on your lab exercise 8 now. So your lab exercise 8, I only want you to do the linked list implementation. So here the same we have the public interface for our linked list. So if you have any inline function, you can write like that. But here is your linked list public interface. So the same thing, please work on your lab exercise. You can using your group page to talk to your group member or to see any other chat app you guys can communicate with each other. Of course, you have question, you can let me know. So when you submit your header file, please make sure to name the header file as lab exercise 8.